Hello and welcome to part 5 of the BT Diamond IP Cloud Automation Quick Start Guide. And as a follow-up to the last video, a couple weeks now, in regards to adding email, I've extended that functionality in kind of version 2 of our Add Next IP address workflow. And I wanted to go over some of the updates and back up a little bit and show you some of the design. And effectively, if you've been following along, show you where I've made the changes so that you can see how this might interact with your processes from your day-to-day address assignments. So really what I want to do then is kind of take a step back. We've been doing all of this along, just kind of building it as we went. I had a general idea in the back of my mind, but to kind of put this out on paper so that we can see what it really looks like, I put it together Visio to do this. So effectively what I want to assimilate in my workflow to provide back to my clients is a means of any type of client to submit a request for IP addresses and to have the workflow determine what subnet to allocate from, the utilization, and to make some logical decisions about which subnet to preference and which ones to allocate from, and again to insert any type of business rules, and then to effectively send different types of emails, one to the end user based on its result, and one to the administrators based on any alerting of utilization or traps along the way. So in that request, we're effectively taking that client and it is submitting to a workflow endpoint that we've created called Add Next IP. We expect that the input JSON, which is the payload, supply the VLAN ID, the quantity, email, and username. The any client here, you would need to determine, and we do too, the type of login capabilities, and I do have a login for the client. So here you can have users log in and or you can do some type of custom process that handles this for the administrator. So we can kind of determine this, but I am actually logging into this via the client. When we take that workflow and begin the process, the first thing we want to do is we want to get a list of an export of subnets that match the criteria of having a user-defined field of VLAN ID that we can export into a list. So we're going to initiate an init export child block API through the node red, and it's going to create and return an array of subnets with that ID. And it can be, and we expect it to be at least one, but it can be one or many. After we get the results, we're going to process those, and we're going to check the availability of each. And I'm then going to insert 2 additional fields into the return packet information of the subnet, or return JSON, that tells me the available and percent of available IPs. I can then apply these rules so that if the subnets do not match this criteria, that it will send an alert to an administrator. We'll capture it here, but it'll continue with the process for whatever subnets are available, selecting one, adding the IP addresses, and emailing the results to the administrator or user, who then can go out and program their devices. And the changes I've added to the alerting here is that we can then set up an alert node and process that will allow a different type of email to be sent in real time when we capture or observe this type of utilization. And here I have in this email formatted out a trigger. So if it's less than or equal to 25% available, it'll then list all of the subnets and what their available and percent are. So these are colon separated. It then lists a separate list of what is available, so we know from a available percent count what's there. And because I am sending this to other administrators, I can also send things like remediation steps. Here's what you need to do to add new subnets that might be available to this particular request in VLAN. So I expect that I'm going to get 2 different emails if I see an alert, and only if I see an alert, and then for the assignment of the addresses. So after I've designed that, and I actually built this before I wrote this, so in the actual image of this and the design structure, I've added quite a few sections here. I've kind of completed some of the error checking and some of the exit points of the workflow where I want to trap on different things like, are there any subnets available, and are there any IP addresses available? And if not, we need to return it back to the client, telling them the error message so that something further can be processed. So we're taking that payload information from the client. We log in with its user credentials or use the header, and then we're going to generate a query string which is applied against the export child block node. So there's a number of payload details we're going to shuffle around in here to specify the quantity, which we put in payload quantity, or actually we set quantity to payload quantity, and we move the input parameters up into some other variables or properties to use later. So that's what we're doing in this particular function, but we're also constructing the import details, and this is actually the query. So it's going to go out and query a VLAN ID, user-defined field, for the VLAN in the payload, and to further qualify it by checking the API-enabled flag. And we'll see that in a minute, but that flag then allows us to dynamically, in real time, add or remove subnets from the available list based on that check flag. So we're going to go in and go ahead and then export the IP addresses for the subnets. And if we have and check that there's a payload, if there is no payload, then I want to take the output and I want to say that there were no subnets and pass an error back to the calling client to that effect. And lastly, I want to exit by sending an error message 400, that's the status code we'll send, that can be checked, back to the calling client to instruct it that, hey, there's no subnets, you can't complete this request. Now, as a follow-up, and it's kind of a logical follow-up here, where we have, kind of put in some of the alerting and others, I might also want to add the alerting to the failed request. So now see in real time that a client requested an address, it failed. We can now go out and see this in real time and go make changes accordingly. Now, if we do have subnets, there's more than 0. Okay, it's not null. There's at least 1. And we go through and split that payload into individual records that we're then going to process. And what we do here is I'm going to construct in the change nodes, moving things around so that I can go back in and construct the get block API syntax to call the next step, which will then go out and call the stats to get the availability in real time. So in that export child block function, there's a stats checkbox to pull back the utilization numbers. And that's what we're doing. And then storing this back into the payload for later processing. Now, when we check the stats in the utility, we're going to join these back into, again, a separate array, which we're then going to parse back into a request. So we calculate the availability and the utilization, and then we set the URL for the next node and deleting these URLs, from the message so we don't have any conflict of message headers. Now, the next step in this is the processing of the return subnets. And this is where we're going to apply some of those business rules that we mentioned and show up here in the design. So these are the business rules here that we're going to manage. And what I'm doing is I'm pulling in the array of blocks, and I'm going to parse those through a for an X block, basically, for an X function. If these blocks, available percent, is less than or equal to my business rule 25, then I'm going to push this into an array, which is going to be alerted on. And if not, it's going to go into the available blocks array. And if there are alerts, we store it back. If not, we don't. And lastly, in the available blocks, I have put a sort function, which then sorts on the available property, which is an absolute number of IP addresses available in that subnet. And I want, in my case, to return a descending order, which puts the -1 first and 1 second, or ascending would be 1 and -1. But I want it in descending so that it gives me the highest number of available addresses. Since I know that then is in order of what the available blocks are, I also want to put for debugging a message available blocks, stores what I actually went out and checked against, and I probably want to disable this at some point. And then I will then again validate if there are any blocks, and if there are none, to create an error message like we did in the previous section. And if that's the case, return the message right away. And if it's not, if there are subnets, I'm going to go ahead and set up another couple of variables that I can use for debugging, and then select the selected block, which turns into your block selection in the packet. And I'll show you that. And then lastly, we then loop through the requested quantity, and I'm building an array of import IP device structures, passing it in the variables that we need, such as things from the start, the domain name, and others, and then also telling it what the host name is for applying host name policies or passed in information. Okay. And then lastly, we're going to feed that back into the payload, which we're going to process for the device adds. Now, what we're going to do here is if I have set an error, if there is no error, then it's going to continue on through the process and call the import. If there is an error, meaning there's no blocks available, send it out to the client and end the process. And if there's an alert, which can be done in parallel to the import, to go ahead and make the switch and email the alert to the administrators using the mustache syntax template and tell them what the alerting is, what the subnets are, what's available, and they can get this in real time. Now the import I modified considerably from our first version and iteration, and where I was before doing the import and then telling it to do the get and all of that in a single process, I wanted to add some troubleshooting and some error handling to each of the different functions and to do them separately. So first I would go ahead and split, run the import device, and join those back into an array. I'm catching any errors. If the import device has any errors whatsoever, I'm catching those, and then I'm going to retry them after a 2-second delay. And the reason I'm doing that is I might be sending these requests too quickly, and in order to maintain consistency and structure, any errors can be retried, so we'll just throw them into an array and then retry it lastly. And that allows us to do things in real time in the process. And then as it merges those back into a single array again, and I move around the payload to make sure now in the next step to pass the IP address, which is passed into the get device. So again, if you need to see this, you can look at the info tab and it'll show you the details of what the input payload should be and the output. I'm going to move that information again from the payload block selection into another array so I can see it later in the message workflow. And then I sort those out, and then I return the response to the user. So this, if you're using a API, this will return the response, and we'll see that in the JQ script. But I'm also emailing this and sending the results to your clients or the email specified. Now, lastly, in here, we're sending the email out, and we're catching any exceptions and processing any errors that allowed us to or not allowed us to complete the process that we didn't anticipate as an error and sending it back to the client. So all of that, handled that pretty quickly and substantial changes, but the benefit of it then allowed me to get real-time information. So if I look at my scripts and going back to the function I was calling an add IP, just a general curl script, which I'm passing the VLAN ID as an argument to the script and the quantity. I'm then the endpoint adding it to the end IP, add IP workflow, add IP, and then it's going to return to me the JQ or JSON, which I'm going to parse through JQ. So if I were to run the script telling it I want 10, and it's going to go ahead and call those through the APIs. It's then going to send me back in that JSON, which I can then see all of the IP addresses and further process this information. But what I'm also going to have then, if I go back and look at the packet output, I'm going to see in the debugging that, hey, there's an alert, number one, and there's an alerted subnet, which was 32.4, and that there were no IP addresses, so it did send an alert. But in the available blocks, this is the block I had available. It could be one or many. And the selected block is the same block in this case. But this could, of course, be a different block too. And these are debug. I'm going to probably turn those off in the end. The response email back to the user is going to effectively show them the details of the VLAN, the type, quantity, the gateway, of course important to the IP assignment, the DNS name, which they'd have to resolve but provides, and then the container and the subnet with the CIDR size. So in terms of the mask and things, we have enough that we can send back to the client the necessary details that can be further provided to other information for configuring the IP stack on whatever device you're going to use. And then we also had an alert which showed in our output, and in that alert I should be able then to see some of the details about that in the email. So this then would be sent out to our administrators telling us the detail, the alert utilization, and here's where it triggered and what triggered, like what subnet and what percent in availability. But I also put in this alert that, hey, you do have a subnet, that there's 587 addresses available, which is 57% of the subnet. However, when this gets to 25, this will trigger and we'll start getting errors that there are no IP addresses. So to remediate this, I would need to go in and add a new VLAN or subnet with a VLAN tag 113, 1113. And this will change, of course, dynamically based on the request. So that's the type of email. And then as an administrator, being able to do something proactively with that. And that's where we ended up handling this workflow, which is kind of extended. And so I think in the very last part of this, I have a couple of more error message workflows that I want to kind of consolidate and send out so that I can see in real time when they fail. And potentially some other functionality that I might want to add back to the user to do something else. But I'm not sure what that is, but get creative. And the idea is that you can get creative. So I hope that you can see some of the value here. And then as we, start running the addresses, we'll start getting these alerts and IPs, and you can use kind of any source to assign the IP addresses and consistently build the workflow process to automate it and allow others to interact with your IPAM solution. So that's our 5th video on the cloud automation appliance. And I think in my next video, I'm going to take a kind of a lateral step and move over to my lab Node-RED system that's not on a cloud automation appliance, but it's running in my lab. And I have some demonstration abilities for MongoDB and potentially some abilities to upload files to Node-RED where you can process them and include those as part of your call out to IP control and others. So some maybe different things of different caliber that might help you in your creativity with these workflows and what you can do. So I hope that helps. Thanks for spending your time with me today. I hope it's not too long. And I'm going to, again, be back soon and hope to see you then. Take care and have a great day.